This is TechSNAP, episode 350. Welcome to TechSNAP, Jupiter Broadcasting's weekly systems network and administration podcast. This episode was recorded on December 28th, 2017, and it's brought to you by our three great sponsors, DigitalOcean, Ting, and IX Systems. I'll tell you more about those sponsors as this here show goes on. My name is Chris, and joining us like every single week is Mr. Payne, Mr. Wes Payne, the presenter, the admin, and the teacher. Hello, Wes.
Hello, sir.
Hello, happy holidays, or actually happy post-holidays. You just got back from seeing family as we record this episode.
That's right, same to you.
Thank you. Thank you. I spent most of it with a cold. A pretty bad one.
Oh,
a fever,
gosh.
if you will. But you've arrived from family town. I've come back from the brink of death to do an episode of TechSNAP.
Now it's time for TechSNAP fever.
Well, let's start with our first news story. Eagle-eyed listeners out there may have noticed that there hasn't been a lot of widespread adoption of TLS 1.3. It turns out Cloudflare has been working pretty hard to get this pushed out there, and they've hit some major roadblocks, and they did a really great write-up about it just like 2 days ago.
Yeah, that's right. So if you're not familiar with TLS, you probably actually are. It's the Transport Layer Security, also sometimes incorrectly referred to as SSL, that's responsible for keeping things secure when you go to those HTTPS websites, hopefully, that you go to. As we know on the TechSNAP program, security is a process, and part of that process is upgrading things from time to time. You know, vulnerabilities are discovered, protocols need to be fixed.
Or new features to protocols need to be rolled out.
Yeah, exactly. So TLS had this in mind. So there's actually something called version negotiation. The basic idea is if I support the latest version, I send a request and I say, hey, let's talk this version. If you support that, great, we'll talk the latest, most secure version. If not, you'll send back the next most latest version. Usually you'll have a list of allowed versions that don't allow known, like versions with terrible vulnerabilities. So it's a smaller list. And one of two things can happen. Either we find a version we both agree on or not. In that case, the connection's closed. It isn't negotiated. So it's a pretty big deal and it's important. It seems pretty simple, but it's actually an example of something known as ossification. Now, if you're not familiar with ossification, it's basically the idea that if you have a flexible structure, but you don't ever use that flexibility, you're going to find people who assume constancy. A great example of this is if you rarely open a door, right? So you have this door, it's very flexible. If you don't use it, those hinges might just rush shut, and the flexibility you thought you had isn't really there.
Oh, okay. I see. And also, you probably have a tendency for developers to develop what's in production versus what the spec says because you want to be compatible. You're selling a device that supports SSL, or you're shipping a browser that supports SSL. The temptation must be support what we're actually seeing in the wild.
Right, exactly. Like you obviously you try to conform to the spec as best that you can, but you also have to support real world traffic. You have to make some considerations. Maybe you don't implement all of the spec, and there's a huge number of these implementations. So really what you find is the real world converges on this minimal shared set of all implementations. And that's usually not exactly what the spec might say. By mid-2016, TLS had a new version, 1.3. It's an ambitious new version, some of the biggest changes to TLS since it was first adopted. It'd gone through 15 iterations. They'd figured out a new version number, all these things. It turns out there was a little bit of a problem.
Some road bumps there, Wes?
Oh, yes. So when some servers were presented with a client saying, hey, let's use 1.3, a large percentage of devices would just disconnect. So even though they supported the older 1.2 that's in wide use today, instead of replying with 1.2, they would just disconnect. So there's a bunch of work, people like at SSL Labs, David Benjamin, they confirmed that the failure rate here was pretty high, over 3% in many measurements. So if we started going ahead...
3% failure rate's considered high?
Well, if you think about the small users on the internet, random people that just, their sites just break if you start implementing this, it's not a huge amount, right? It's not 10%, it's not 50%. But when you're making this kind of large distributed change, 3% is maybe enough.
And I guess it depends on who's in that 3%.
Well, absolutely it does.
And so what is the major hiccup with getting TLS 1.3 adoption rolled out? Is it Chrome? Is it Firefox? Is it the browsers that are dragging their feet? What's the problem?
No, the browsers are pretty invested in this. They want to see these new, the new protocols rolled out. A big problem here is middle boxes.
Like SSL interceptor boxes?
Yes. So there's some malicious or nefarious SSL interceptor boxes that are deployed either on corporate networks or by certain 3-letter agencies. But there's also just a lot of other middle boxes, right? So like if you think that there's a bunch of load balancers out there that do SSL termination.
Sure.
So they have their own TLS stack that they're implementing there. There's a ton of those systems that just sit at gateways as part of interconnected networks, and all of them have their own different, often proprietary, implemented in firmware or ASIC implementations of TLS.
Oh boy. I hadn't even thought of that. Of course they're going to be hardware accelerated, which makes that even more trickier. It's almost like the TLS team has to shift gears and they have to write to the middle boxes now instead of the middle boxes writing to the TLS spec.
Yeah, exactly. So one thing was recently proposed to try to get around this, and it's somewhat a controversial idea, but basically you pretend you're 1.2. So the very first message that you send as a 1.3 capable client, you just basically say, hey, I do 1.2, but also I have this new extension. And so besides version negotiation, there's also this extension mechanism. So now there's a new version extension, which then lists that it supports 1.3.
So what you're saying to me basically is they took some of the improvements in 1.3 and crammed them into an extension, and then they just sort of tactfully downgrade?
Yes, exactly.
Yeah, I guess that makes sense because then essentially you can sneak by all these interceptor boxes.
Right.
They keep working, but if you happen to talk to a server that's capable of talking 1.3.
Yeah, and that's a really key point here is that this was something that largely was only seen implemented on actual back-end servers. So if you're talking and you don't have any middle boxes, you're talking to some server that's actually doing the SSL termination and no one is man and middling this, that'll work great. It did work, Unfortunately, it's not the end of the story though, because as you're saying, there's all these middle boxes, and how often do you upgrade those, right? It's not like apt-get install nginx. It's, we just spent $150,000 on a new load balancer. So you can't just say something that was invented like 3 weeks ago would actually be in effect there. There's more problems than just that.
Right. So back in February of 2017, both Chrome and Firefox started enabling TLS 1.3 for a percentage of their customers. And in fact, I think my version of Chrome has it right now. The results were unexpectedly horrible, though, back in February.
Ugh.
Bad. A much higher percentage than even, 3% before? I think they started creeping up towards 4 or 5%, which was higher than they expected. No matter what the website, TLS 1.2 worked, but TLS 1.3 would not.
And that could be a pretty terrible end-user experience. You upgrade Chrome and suddenly you can't get to your bank. Yikes.
And they hit this roadblock the entire development process through 1.3 because they initially tried a different version number and that horribly broke things. And it just really came down to these network appliances making assumptions about how protocols would evolve over time. And when faced with a new version that violated some of these assumptions, the appliances would just fail in various ways. Now, for some context here, earlier this year, Cloudflare did a HTTPS interception study, and they found that between 4 and 10% of the web's encrypted traffic is being intercepted by these boxes.
Yikes.
So it's not the sole cause of these problems, but they are a major contributing factor.
Yeah, no, I think that's absolutely right. And as you were getting at earlier, implementers implement to the reality of the protocol and not the intention of the protocol's designer or the text of the specification. And just in complex ecosystems, unused joints rust shut.
That's an interesting metaphor that Cloudflare uses because the fix for this turns out to be a project called Grease.
The idea behind Grease is we really want to keep these joints oiled, right? We see that if they're not used, then implementers don't have to deal with worrying about, hey, could this value change? So Grease is a proposal for TLS that's designed to throw in random values where a protocol should be tolerant of new values.
Now, how about this for a workaround?
Yeah, right?
Interjecting random values just to kind of stress test it while it's in production.
Yeah, so if popular implementations intersperse unknown ciphers, extensions, and versions in real-world deployments, that part's key, then implementers will be forced to handle them correctly, right? So if you know, and if you go look on your real network and suddenly you're seeing all these things and you can't just assume, right? It's one thing to say oh yeah, I'll get my input and it'll be from this list. And if that's always true, then there you go. But the second you get one of those nope, my assumptions are violated, now you have to code in a more robust way. Grease is a little bit like WD-40 for the internet.
That is hilarious. Now, they note that even with Grease, some of the servers that were surveyed were still found to only be intolerant to TLS 1.3 as of late December 2017. Grease only identifies servers that are intolerant to unknown extensions, but some servers may still be intolerant to specific extension IDs.
Right. So it's really not the end of the story, but it's some proactive efforts here to make sure that parts of things that can change will actually get changed.
What do you think about Cloudflare here kind of taking a proactive role in promoting TLS 1.3? They've been working with Mozilla Firefox to get this out there, to get it measured. Google and Facebook have been doing their own measurements. They point out that these experiments are hard to perform because developers need to get protocol variants into browsers, which can take entire release cycles, which is often months, to get in the hands of end users before they can really start doing any testing on production equipment.
Yeah, right, exactly. And I think it really goes back to this decentralized nature of the internet and all the different parties that are involved. It's pretty hard to get a real end-to-end picture of everything that goes on, considering all the different options there are. I am pleased to see, especially as Cloudflare terminates a lot of traffic on the internet these days.
Yeah.
So it's important that they do things. I really appreciate that they publish some of these interesting guides and give us a little bit of a background into what's going on there.
If you want to test your network connection to see if there's a middle box between you and the server that you're talking to, we'll link to a test. Go to techsnap.systems/350, and we'll have a link in there, the TLS 1.3 middle box test. And they can also do, if you want, they can also do additional man-in-the-middle detection. I tried it. I passed. It turns out here at Jupiter Broadcasting, we're not intercepting my SSL traffic. Relieved to know that. But try it out yourself at home, audience, or at your work, and see if somebody is intercepting your SSL traffic.
Yeah, maybe we can help Cloudflare get some more data, and someday we'll be able to have nice things.
And you know what? I should stop. It's not SSL. It's TLS.
That's right.
It's
Come
TLS.
on, get it right, Chris.
It's time to make that change. It's a 2018 resolution. ixsystems.com/TechSNAP. That's where you go to support the show, tell IX you heard about them here, and also learn more about this crazy great company. They've been around for a long time, and I got to be honest, I am not unbiased. I've been a customer of theirs, and I love this company. A big part of Jupiter Broadcasting runs on IX Systems. They're big champions of open source. IX Systems believes that open source technology has the power to change the world through its process of open collaboration and innovation. And that's why they're big contributors to TrueOS, FreeNAS, FreeBSD, OpenZFS, and many others. They build that expertise back into their products, and then they create deep relationships with the various hardware vendors at every level, from the case to the CPU up to the disk. They have these deep relationships that go back years now. They have deep insights into how the code actually works on this hardware, and they contribute a lot of fixes, new code, ideas, and more back upstream to these open source projects. And it all comes together in their great products. From the FreeNAS Mini, the TrueNAS all-flash and hybrid arrays, and even their huge cloud in a rack systems. They have solutions for big data, education, development, finance, government, healthcare, high-tech, manufacturing, media, entertainment, all virtualization shops, or if you just want to back up your data, ixsystems.com/TechSNAP. Leaky buckets have been a big problem this year, and it's one of the most basic configuration mistakes companies can make. And we've got a pack of leaky bucket stories. Let's start with the one that in TechSNAP tradition has personally affected me and leaked my information on the internet. DJI, the Chinese drone maker, left private keys for its .com's HTTPS certificate exposed on GitHub for up to 4 years, according to a researcher. 4 years.
Yikes.
DJI also exposed customers' personal information from flight logs, copies of government IDs like your driver's license, and all of this was just due to misconfigured AWS S3 buckets, which is surprisingly common. We're going to tell you about a couple more, but this one really hurt because not only did they leak the wild SSL cert private key, which covered star.dgi.com, including security.dgi.com.
Yeah, nothing bad could happen with that.
Yeah. Now, they did revoke the certificate.
Okay,
so
excellent.
that is actually been taken care of, but it was sitting for 4 years before it got revoked on a DJI-owned GitHub repo. In that same repo, AWS account credentials and firmware AES encryption keys were also exposed on GitHub, along with people's highly sensitive personal information that I mentioned. Unencrypted flight logs, passports, driver's license, identification cards were just a sample of what this guy was able to get a hold of. So the researcher, his last name is Finister, and he tried to work with DJI's bug bounty program so he went through that whole process. Here I found this thing, and they start having a back and forth, and DJI is like, yeah, I think you have earned our top reward. That's $30,000.
Wow.
Yeah. There was just one problem. The terms of the non-disclosure agreement that DJI wanted him to sign, which I guess after some debating, he just gave up on, and he posted an 18-page PDF on Twitter with all of his frustrations with DJI's bug bounty program outlined, all of his findings outlined. And in this PDF, you see that he even had correspondence with DJI where there was essentially a thinly veiled threat where they warned that they could go after him for the Computer Abuse and Fraud Act.
Wow.
Yeah. When they sensed things were going south, they started to try to play hardball. This is example number 1 of leaky buckets. And this is such an easy problem to solve. And here's another one. UpGuard, security researchers on October 6th over at UpGuard. And these researchers found an intriguing 36 gigabyte database just sitting on S3 in plain view.
Wow.
In a bucket.
Just right there.
And
for anyone to access.
It has information on essentially all U.S. homeowners. So if you
something like 123 million?
Yeah. Yeah, it's data that's been collected by a company that's been monitoring you for years if you're a homeowner in the States, but you've probably never heard of, Alteryx. And they set up an S3 bucket to store this data in, and guess what? It leaked out. Regardless of whether you've ever heard of Alteryx or not, if you're a U.S. householder, they have a humongous trove of personal data, and it was sitting on S3. So what was in this 36 gigabyte database besides 123 million rows, all with 248 columns of data? It was things like your address, your telephone number, your estimated income, your home evaluation, the last car you bought, what magazines you subscribe to, how much you like to travel. Even if you own a cat, that was in there. All UpGuard needed to do was just sign up for a free Amazon Web Services account that anyone could open and then get access to the data.
Pretty low barrier to entry there.
If that's not enough, the U.S. military also was recently subject to a leaky bucket, thanks again to an AWS S3 misconfiguration. A lot of information, dozens of terabytes of social media posts and similar surveillance data that this is really unbelievable, the U.S. military was collecting on citizens, both abroad and locally, and the archives were just found by UpGuard again, sitting on S3, named CENTCOM.
And they only sort of control the Army, Navy, Air Force, Marines, and Special Ops, so that's not important.
What's crazy is, do you know how they found this? Is they just accidentally were running a scan for the word com in publicly accessible S3 buckets.
Wow.
And then that's when CENTCOM popped up, and then that's when they just started going crazy. They downloaded 400 gigabytes of samples.
I would too.
They say there's terabytes up there. Mostly it's compressed text files that can expand out by a factor of 10. There's dozens and dozens of terabytes out there, and they say that's a conservative estimate. Just one of the buckets contained 1.8 billion social media posts that were automatically being collected and parsed. And it's current as of the day that the researcher found this, from going back 8 years. There's also interesting clues, which I think is the more revealing thing here, about what the information's being used for. Now think about that for a second. Digest that for a moment. What this researcher uncovered wasn't just a misconfigured S3 bucket, but they revealed what the U.S. military is collecting about people, like the surveillance that they're conducting. So strategy has essentially been revealed here.
Yeah, there's a lot of intention and direction here.
Documents in the buckets make reference to the U.S. government's Outpost program, which is a social media monitoring and influencing campaign designed to target overseas youths and steer them away from the terrorism. So there's like a batch of 3 misconfigured S3 buckets. And it feels like there's really no excuse for this anymore. Amazon has even made changes over the years to really kind of call out the fact that you have not configured this correctly. Hey, there's big yellow lights that come up, and yet still, to this day, this stuff's going out.
Yeah, absolutely. It does, I think, say a little bit something, too, about just the dominance of AWS in the current marketplace. And so it does make it, having this single provider makes it, if you were trying to find documents, right, where do you go to scan them? You go to S3. There's already a bunch of software that exists to try to like brute force scan different S3 buckets, because a lot of them by default, right, they're public addressable names. So you can just start poking at them.
And in regards to DJI putting their keys and their AWS credentials up on a GitHub repo, we've seen a lot of that too.
Yes, absolutely. And, especially the more and more we're using cloud services, we're using hosted services by other companies, you have to be really careful, and you really need checks and balances in place, especially if you're going to do things in an automated fashion, right? If you have any kind of like continuous integration software,
automatic deployment,
any of that, you really need to make sure that you have things set up in a good way. And thankfully, there are some tools that you can use these days.
Yeah, Netflix makes one, Security Monkey, which monitors AWS and OpenStack and other public and private clouds, and it looks for insecure configurations or like credentials that you maybe accidentally uploaded.
Yeah, definitely. That's definitely something to check out. As well, AWS has some tools that you can set up too. So really, I think the key here is AWS is great. You use it. It's super. It solved your problem. It was simple. but you really need to make sure that if you're going to integrate it into your production environment, that you have auditing trails set up, that you have ways to check and make sure that resources are controlled, just like you would with any other sensitive resource.
Well, we've known this for years and years and years when it comes to on-premises systems. Like,
right.
Your misconfiguration can lead to a total breach. As these cloud-hosted systems like AWS, which are extremely sophisticated, just add more and more functionality, add more and more capabilities, add more sophistication, you have to be just as studious about your configuration there as you would a web server that's running in a DMZ on your LAN.
Exactly.
DigitalOcean.com. Go over to DigitalOcean, create your account, and apply our promo code SNAPOcean and get a $10 credit. SNAPOcean, it's one word at DigitalOcean.com. Now, why would you want a DigitalOcean account? Because you know what's up. You can get started in less than 55 seconds. Every system you deploy is backed by beautiful, fast, the best, the greatest SSDs. In fact, DigitalOcean is one of the early pioneers on hosted services based on SSDs, and they also built the best dashboard in the business. If you're a long-term server admin or completely new to building a server, their dashboard has you covered. And then once you get rolling, you'll really take advantage of their API. You'll love the intuitive API. All the command line utilities are already built around it, as well as some stuff that's really great for large-scale workloads. They have block storage and object storage, monitoring and alerting. You can collect metrics, monitor performance, and receive alerts to optimize your application performance at no additional cost. Oh yeah, and 40 gigabit connections to their hypervisors with load balancing as a service. DigitalOcean.com. Use our promo code SNAPOcean after you created that account. And a big thank you to DigitalOcean. Check out their straightforward pricing. My favorite rig, my personal recommendation, 3 cents an hour. 2 gigs of RAM, 2 CPUs, 40 gigabytes of SSD, and you can attach as much more as you want, and 3 terabytes of transfer for 3 cents an hour. DigitalOcean.com, promo code SNAPOcean. When things slow down, like prime holiday season, we're going to take that opportunity to cover some of the fundamentals. And this week, we want to do an introduction to the SMB protocol and really how you can look at that to monitor security on your network. Do some security analysis around SMB. Now, this is applicable to both Windows users and Linux users, and we generally talk about this stuff at a much higher level, more at the application level.
Right.
And this week, we're going to go down to the network level.
Yeah, there's some great resources over at 401 TRG, which is like the threat research and analysis team over at ProtectWise. So of all the common protocols that you're really going to see, on a typical production or corporate network, perhaps none is quite as impenetrable as SMB, also known as Server Message Block, or Samba. Its enormous size, sparse documentation, and wide variety of uses can make it one of the most intimidating protocols to get an understanding of. Not to mention just setup, but even to go try to introspect what's happening on your network. At its most basic, SMB is a protocol to allow devices to perform a number of functions on each other over a usually local network. SMB has been around for so long and has so many different backwards compatibility features built into it that have been accreting over the years. It contains almost an absurd amount of vestigial functionality.
Which, going back to our TLS discussion, often leads to problems in the future.
Exactly. At its core, though, today SMB is mostly used to map network drives. If you've been on a Windows network and had network shares, you've almost certainly used it for this. Send data to printers, read and write remote files, perform remote administration, and access services on remote machines. Now, that's a lot right there.
Yeah, and I think a lot of times when people think of SMB, they purely think of the file sharing aspect of it.
Yeah, you're right.
Server, as the name applies, server message block is all kinds of things. And that is when you're looking at this from a security standpoint where things can go awry, because you can use the SMB protocol to do remote command execution. In fact, Windows has facilities just built right in by default.
Yeah, exactly. And that can be a huge part of the problem.
So just for the basics here, SMB runs directly over TCP port 445 or over NetBIOS, usually port 139 if you roll that way.
Right. To start an SMB session, the two participants agree on a dialect, authentication is then performed, and the initiator connects to a tree. For most intents and purposes, the tree can be thought of as a network share.
Okay.
Now, if you take this and open it up in Wireshark, right, so you've done some captures on your network, you're trying to look around, you're going to see a lot of information. And it can actually be quite difficult to tell, what's actually relevant here. If you've done, any sort of network analysis, that's often the case.
Yeah, it's both a blessing and also a curse, because sometimes you can just read in clear text what it's doing, and other times it's really kind of confusing. And there's hidden shares, there's weird connections it makes.
Right. So, two important ones you need to know to understand any of this is admin $, an IPC $.
Right. And in Windows parlance,
Yeah,
or even
exactly.
in SMB parlance, the $sign means it's a hidden share.
Yes. So the admin share can basically be thought of as a link to just C/Windows, right? So it gets you right into the administrative center of the PC.
But think about that for a second. By default, at least when you're in a domain, the admin $sign share can be set up automatically with no knowledge of the user, and it goes directly to the Windows.
Right to Windows, yep. So, and then on the other side, the IPC share. I mean, if you know what IPC is, you're probably guessing. It's a little bit different. It's not a file system mapping directly. Instead, it provides an interface through which remote procedure calls can be performed. And to many of you, I'm sure this is already setting off warning bells.
Yeah, but at the same time, this whole remote procedure call system makes managing multiple Windows boxes very nice for a network administrator.
That's a good point.
So let's focus on the security aspect of this, so that way we can give some people tools to walk away with where they can look at their own SMB traffic. Because I think if we focus on security, then that's the most practical thing. Like if you were to look at just say authentication in SMB, you can tell a lot.
Yeah, absolutely. An unusual login on a device can be a thread that unravels to an entire attack vector, right? So there are two ways to authenticate in most deployments, NTLM and Kerberos. NTLM is the older of the two. It's been in use since, get this, the release of Windows NT in 1993.
Oh, yeah. They've done a few revs to it, but yeah.
But it remains supported in the latest versions. So it uses a user's password hash to encrypt a challenge. So like you send it a challenge, it takes the hash of the password, encrypts the challenge, and sends it back to you.
Yeah, and NTLM is pretty common on a workgroup setup. Generally now in later versions of Windows, group policy has been preset to like require signing, to require a specific security version. But just like in the case of TLS, on a wider, larger network, there is a mechanism in place to automatically downgrade NTLM, which can cause attacks in certain cases. So generally, it's considered more secure to use Kerberos with Windows authentication.
Yeah, exactly. And while it's more secure, it can also be more complicated because it's not really directly a part of it. Kerberos authentication happens separately from SMB.
That's an interesting fact, too, is that I didn't realize that until this article, is that the Kerberos ticket mechanism isn't integrated with SMB at all. It's a totally separate authentication mechanism that then authorizes the SMB session.
Yeah, exactly. Plus, a lot of the attacks on both NTLM and Kerberos, they can be really hard to detect at an automatic network tracing level, since it really just often looks like legitimate user logins.
Right.
So this, like, it's important here that you should have some reasoning, have some control lists set up so that you know, like, if this user has access to this group of machines, and if you see logins on other machines, that's a warning sign.
Now, the thing is, though, if you're using a Linux box with Samba on it to do just basic file sharing over your LAN, or you have a couple of Windows 10 boxes on your LAN and you're not part of an Active Directory domain, you're probably not using Kerberos. In fact, you're almost
certainly not.
Yeah, because you need to have a ticket granting server. You need to have a naming system. You need to have a network time server set up. You basically need Active Directory.
Yeah, exactly. Or to roll your own, which is undecidedly complex.
Yeah, exactly. So this applies to a lot of different work cases depending on how your network is set up. But both of them can be different vectors. Obviously, if you're looking at a network level, the NTLM stuff is easier to watch. Like if you're just watching in Wirecast, it's much clearer to understand what's going on with NTLM.
And that's why it's really key for network defenders, anyone interested in what's going on the network, to have a good understanding of which users should be logged in where and have good discipline about which accounts have access. Don't grant access to everyone, to every box. Do it as a, as needed basis. Yeah, simple principles like that.
I agree, because if you have that stuff clearly understood, then it makes it so much easier to spot unusual traffic.
Yes. And occasionally, as always, we're on the spectrum of security or convenience, but we can't always be on the convenience side of things.
But really, if you're going to go after a box that supports SMB, you're probably going after the RPC aspect, the remote procedure call aspect, and not so much the file share aspect of it.
Yeah, absolutely. One of the things you can use it for is to enumerate users and groups. So a thread in this whole story is what's often called lateral movement. Other people call island hopping. But this idea that you can gain entry on a network, you have access to one machine, and then you can use that to get access to more privileged accounts to more important machines. A practical example of this is a pretty common Windows administration tool that maybe you've used, PsExec.
Oh, yeah. Big fan of the sysinternals tools. That makes it a lot easier to manage a Windows box.
Yeah, exactly. On their website, they describe it as a lightweight telnet replacement that lets you execute processes on other systems, complete with full interactivity for console applications without having to manually install client software.
Oh boy. So
right?
that's got a few trigger words in there. Telnet replacement is one of them.
Yeah, right. Telnet just at all. Ugh.
Complete and full interactivity for console applications without having to install client software is another one. Obviously ripe for abuse. And it's pretty interesting how it uses SMB. PSExec uses SMB. It's using that IPC $ share to initiate a connection. But what I didn't realize in the background is that first it connects to the admin $ share. If you recall, is essentially a symbolic link to see Windows.
Yes.
It copies a PSExec service.exe file over to the admin $ share. And then it uses the IPC $ share to execute it and launch it as a service.
And there you go. Once you've got PSExec running, I mean, the number of things you can do is almost unlimited. A common one is to add a user to a remote machine, maybe a user you already have access to. If you can then add that user to another machine, now you have access.
Yeah, the tricky thing, too, with PSExec is starting with version 2.1, it encrypts all of its communication between local and remote machines. So there's not a lot you're going to get if you're watching that traffic.
It's just more encrypted traffic over your network.
Yeah, so you're going to really have to kind of pay attention. Again, this is where it comes back to understand what machines should be logged into which other machines and what accounts they're using. And I love PSExec, but you could totally see how you could just use it as a malicious tool like that.
Yeah, exactly. And it's just so common, right? You want to have easy things. You want to have fast access to machines when you need to troubleshoot them. But anytime you make that nudge towards convenience, you're sacrificing security.
Yeah, and I've absolutely rescued a crashed system or brought a server back to its back to life using PSExec. So I mean, that's the other side of that tool like that. Something else I particularly like that you could do is you might be able to use PSExec to get onto another Windows box and then use a tool to dump the memory for all the logged in users and then sift through that. Because the ticket information for like a Kerberos ticket is stored in RAM.
Yeah, exactly. So like, let's say you've already gained credentials. You have local admin on a box. You can then just dump these credentials from memory and get and then now you have credentials on another box.
So with that background, let's talk about storage krypter, which has been ransomware that's gotten a lot of attention this year. And Michael Dexter did a great write-up for IX Systems. This isn't a sponsored post. In fact, we're basically giving away the milk here. But we just thought it was great, so we wanted to include it in the show. He says storage krypter ransomware appears to be targeting NAS systems around the world, but the facts around it have been somewhat confusing. Hats off to the most buzzword-loaded headline of the year, storage crypt ransomware infecting NAS devices using Samba Cry.
Oh, no!
Yeah, Samba Cry is the key thing here. Now, first of all, it's not storage crypt. So that's the thing that I think bothers Michael Dexter the most.
Right there.
It's storage krypter. Storage crypt appears to be legitimate software, so you kind of feel bad for storage crypt because
that hurts.
This storage krypter story has dominated the Google juice now. So storage krypter uses Samba Cry to do ransomware encryption of remote Samba file shares. The victims are finding that their files are renamed with .locked extensions, and then there's also a text file in there that says readme for decrypt.txt containing information on what's happened and how to get the files back. Some users on Windows see an executable that's in Asian characters.exe, which translates basically to the Beauty and the Beast, which is then accompanied by an autorun.inf, which is supposed to auto-launch it.
Right.
Now, there are actually two vulnerable NAS systems, or the actual NAS itself. It's Western Digital's MyCloud, and then another unit. The free NAS boxes are not vulnerable to this. But the Windows machines that connect to it, I suppose, in theory, could be.
Yes.
And the Samba Cry vulnerability is where this comes into play. If you recall, Samba Cry, or its sexier name, CVE 2017-74-94, as we like to call it, haha.
Or Eternal Red.
Yeah, or that, sure. Allows a carefully crafted Samba shared library to be injected over network port 445, which provides the attacker a path to write to a share.
Right, and it's similar. It's basically a Linux or a Samba the open source version of SMB. It's that version for the WannaCry vulnerability on the Windows side.
Okay. Thank you for the clarification. I was not making that clear enough. In the case of storage krypter, what happens is essentially it's software that pulls down Samba Cry and then uses the Samba Cry vulnerability to get access to the machines. In fact, quite literally, what the core storage krypter executable does is a wget where it pulls down a Samba Cry shell script and then chmods it executable and runs it. And then
talk about your script kiddies.
Yeah, and then your files are encrypted. And so you do have to kind of be aware of this, because if you have clients that are connecting to the machine over the network, they could potentially spread this thing around. having your NAS itself get directly infected, which is what all of the news stories reported this year, is kind of crap, except for those 2 models that run Linux that could actually be affected by this. But I think the point that Michael Dexter makes, and I think it's the one that we should end on with this story, is if you have the means, take snapshots, do backups. I know you know this, dear audience, but it is the one and true proven method of never having to pay a dime to ransomware.
Right, yeah, exactly. And I think this really underscores like even if it's a little hyped, the potential of your NAS being attacked. One backup doesn't count, right? You can't just put your files on your NAS in your home and say like, yes, those files are safe forever, because as we've seen, if it doesn't exist in like 2 or 3 places, it just doesn't exist.
Another thing you can do, especially if it's like a FreeNAS box or a standard Linux Samba server, and it's possible on Windows too, is you could disable admin $. You could turn some of these default shares off,
yes,
which is something you might want to review. Now, what about a 2018 prediction? Is 2018 the year that ransomware goes after snapshots? I mean, OpenZFS it's out there for the public. Somebody could analyze that and figure out how to go after the snapshots, I would think.
I hope not.
Well, there's one thing you could do. You could set exec equals off in the OpenZFS property on your shares to prevent malware execution. So if you have shares on an OpenZFS array, and there's never any reason anyone ever needs to exec code off of any of those shares, why not put this in there? Exec equals off.
Yeah, exactly. You're
Problem
safer
solved.
right there.
I did that a lot on my Samba servers that I ran for the various clients that I had, and also for the financial institution that I worked for many years. Is I would just completely blacklist .vbs, .exe, and a lot, because you can say do not accept these file types at all. They just don't even get written to the share. And that's another thing you can do to help prevent the spread of some of these things. Now, it won't solve Samba Cry, but it did, I think, solve a lot of problems, especially in roaming profiles, where users would download crap in their web browser history. And then when they would log out, it would attempt to load that stuff back.
Put all those right on the server.
Right, and with these options, I could just basically drop all that.
Yeah, I think this is also a good reminder that there's really basically 0 reasons you need to have a publicly accessible or publicly exposed Samba interface. Just don't do it.
No, you can if you have to get access to those files, there's other methods.
Yeah. Use a VPN, something similar.
For God's sakes, use a web app that enumerates your files. Just don't put Samba.
Don't put Samba exposed to the internet.
Don't do it. That's the TechSNAP advice of the year right there. Yeah, and check your default paths. Check your default paths. Check to see if maybe you could be doing snapshots. That's gonna be your bulletproof solution. Again, until they go after them. TechSNAP.ting.com. TechSNAP.ting.com is where you go to do mobile a bit better. And when I say a bit better, I probably mean the real way mobile should be done. The actual way mobile would have to be done today if it was a competitive market. It's just a smarter way to do mobile over at Ting. TechSNAP.ting.com. The average Ting bill, just $23 per phone per month. Oh, how do they do it? It's easy. You just pay for what you use. That's it. Minutes, messages, and megabytes plus $6 for each line that you want. You want 1 line, it's $6 a month. You want 2 lines, $12 a month. Plus, Uncle Sam's got a couple of cuts in there. He always does, that Uncle Sam. Nationwide coverage, no contracts, a dashboard for days, and customer service that will blow you away. TechSNAP.ting.com. They have a CDMA and GSM network to choose from. Lots of devices, or you can bring your own. Go check their BYOD page. They had, I think, depending on when you're listening to this episode, it may actually still be going on, a great sale on Motorola devices. I'm betting that's wrapping up right now, but they still have a ton of selection, bunch of great devices. And if you go to TechSNAP.ting.com, they'll take $25 off a purchase. TechSNAP.ting.com. Thank you for going to TechSNAP.systems/contact for sending us your feedback and your questions. We got a follow-up from last week's question from Yusuf.
Oh, great.
Remember, he was having the DHCP decline, just totally spamming his log. I really appreciate that Yusuf followed up with us, because I don't know if you and I would have landed on the solution without ever getting our hands on the box.
Right.
He says, I have a hypothesis. When DH client is offered an IP, it attempts to look it up in the dhcp.leases file, which is stored under /var.
Right.
And if /var is currently experiencing errors, the lookup then fails. It says can't find the file. And then you get a DHCP declined in the log. He says, now I think I understand what's happening. What I need to do is make the server tolerant to such behavior by rate limiting incoming DHCP discover packets, which I do not yet know how to do. I don't know why he still doesn't want to fix the /var issue.
Right. That's definitely something to look into as soon as you can.
Yeah. You might also be able to change where that file is stored potentially. I'm getting the sense, if for those of you who didn't catch last week's episode, Youssef here has a big cluster in Egypt that he's working on, and he can't make a lot of changes to the systems in this cluster. But he's obviously having some problems, and one of the problems is that apparently he can't access /var properly, and one of the side effects he's having is it's spamming his log with DHCP decline issues. And I wonder, Yusuf, if you do get to the bottom of this, if you couldn't just solve it by changing where the DHCP leases file is stored.
Yeah, definitely. And he hasn't quite made it clear what the issues are. Maybe he's supporting the server in question, but not necessarily the client machines, and that can be a tough situation to be in.
I'm invested. I want to know. I got to know, Yusuf. So let us know, and let us know eventually how you resolve that. Good find on the /var, though. I don't think I would have found that myself unless I actually got hands on that box. So
I would definitely still recommend looking into EB tables and IP tables. IP tables even has a feature where you can sort of try to match against arbitrary 32-bit packets. Basically, you can just match against those values. So you may be able to craft things either by MAC address or by looking at the packets themselves and come up with a arguably hacky but perhaps workable solution.
Yeah, I guess if you can't
fix the clients, maybe that's your only choice.
Yeah, isn't that a funky solution? That sounds like Mr. Scott gluing together the warp drive to keep things running.
Exactly.
So Zedman4 writes in and he says, "Nice one, guys. I really like the new format a lot. Please keep up the great work, but do give some free BSD love from time to time, as many of us run BSD and Linux on our servers. By the way, I also like the length of the new episodes."
Oh, okay.
Yeah, so this is something you and I have talked about.
A lot.
Yeah, how do we proportionally cover BSD? Because we also know there's a lot of people in the audience that use it. We have it on a few systems, and both Wes and I generally have the mindset, and speak up if I'm not accurately stating your opinion, but I think we both generally have the mindset based on our conversations that we've had. You just use the right tool for the job. And if FreeBSD is the right tool for a particular situation, we will talk about FreeBSD. And it's not really like a preference situation. We may lean a little more Linux because that's what we use more in production, but that probably more accurately reflects the market and our audience too.
Right. So we would like to walk that line, and we don't want to be on one side, right? Like we've both used and loved FreeBSD in many contexts, much like Linux, and I've been frustrated with both operating systems as well.
Mm-hmm. And speaking of Samba, one of my first real experiences with FreeBSD was when I had a heck of a problem. I ran SUSE Enterprise Linux as my Samba servers everywhere, and there was two bugs that were really, really screwing us up. One was a typo in the DNS resolution library that we had to custom patch on all of our SUSE boxes, and if it wasn't fixed, essentially Active Directory support was out the window. The other problem that we had was there was a bug in their Adaptec SCSI driver, which our Dell servers at the time used, and it was tanking our throughput performance to the array. And as a Samba server that was supposed to be responding to 700 users login, which everybody logged in around the same 15 minutes in the day, so the system would just get hammered.
That's just not going to work.
And on the SUSE box, it was causing logins to really delay down. 5-minute login, which people were really starting to complain about because they'd have customers standing at their
and you couldn't get their job done.
Yeah. So I had to fix this problem, and I learned about this bug, and in testing, I decided to load up FreeBSD, which didn't have this driver bug. And oh man, it was the first time I had ever used anything but SUSE on this hardware.
Yep.
It was unbelievably fast. And so we ended up rolling out on that specific hardware that we had in production, we ended up swapping out SUSE for FreeBSD and putting Samba on there. And I really then had to learn the ports collection, how to keep my ports up to date, how to update the base system. Really a different layout for where the configs are at, but I could immediately appreciate the cohesiveness of the operating system. Early into it, years ago, I could tell that the same team that was involved with one tool wrote the other tool. Some of the syntaxes were different, but they made sense once I learned them.
Yeah, exactly. You can tell that there's been a lot of design and care put into the system.
And when you're new, having something like the FreeBSD manual is supremely valuable. And I just printed that sucker out, and I had it in a binder with me, and I just read it off the paper back then. And I just thought that was the greatest thing ever.
It can definitely be better than, outdated Stack Overflow answers. You summed it up well. Sometimes it's just the best tool for the job. And I think that also speaks to the fact that it's great that we can have multiple competing open source operating systems that can all do the job. And this is a good reminder, Zedman, that we do have more Linux experience, but FreeBSD and Linux interopt in any number of ways.
Yeah.
And so I think we'll definitely make a good effort to try to make sure that we respect that and cover it whenever appropriate.
Now, just to kind of cover some ground here, I think this is going to end the new show feedback for a little while. You guys are welcome to keep sending in if you like.
Please do, yeah.
I wanted to touch on why you no longer see our faces. A lot of you download the show in audio, but many of you watched it, about 20 to 30% of you. And for a long time, I felt like TechSNAP had been trapped in this funky middle ground between audio podcast and a video production.
Yeah.
So it was a constant pain in our butts, constantly. There's all these little things behind the scenes we had to deal with, and it resulted in either the audio product or the video product being very good. It's just, then you combine that with the uncertain future of YouTube. What we decided to do with TechSNAP is just focus on what we can do really well, maybe even better than most if possible. And by doing that, build us all a solid foundation of shows for JB, build up revenue over time, and keep super serving our podcast audience, which is way bigger than our YouTube audience. And once we get in a secure position doing that, we'll launch new initiatives like perhaps bringing video into TechSNAP or bringing video into Linux Unplugged, but we'll do it the right way.
I think for me, what has really shined about this new approach is that I think at its heart, TechSNAP is about, explaining complex topics well in an approachable way to interested people. And video, it didn't make it impossible, right? But it can make it harder. And I think the current format lets us focus on that.
Yeah, that's a big thing for us, is we can focus on the stories, the content itself, not so much the presentation of it. It makes it easier to deliver the content, and with support for chapter markers in most modern podcast players, we can still throw up occasional visuals, which I'm still getting a ton of great feedback about. So it's sort of striking a middle ground that I think puts us in a really solid position. But definitely one of our favorite things about the TechSNAP of old was the feedback section, the questions, and all of that. So do send us those in. We need to stock those back up. techsnap.system/contact. Get your questions into the show or drop them in the subreddit, techsnap.reddit.com.
It's a great way to get the discussion started.
Yeah, I like this back and forth with Yusuf we've had.
Exactly.
And we'll try to cover them in a future show. techsnap.system/contact.
We spent a lot of today's episode not talking about it directly, but referencing the cloud and the trends in the software industry. But what not everyone always notices is the cyclic nature. And so we had this big boom, this push to personal computers, and now we're kind of re-centralizing in these big cloud providers. But 30 or 40 years ago, those were mainframes.
Yeah, that was my first introduction to really big computing, was these IBM mainframes. And it's that whole concept of, we would have called it cloud computing back then. We just weren't as obnoxious as we are.
Yeah, marketing hadn't advanced to the current state of the art.
There's a great post that we'll link in the show notes by Ken Schriff, and it's debugging the core memory of an IBM 1401, which was a popular business computer for the early 1960s. And check these stats out. You ready for some of these specs here? It had a 4,000 character internal core memory unit.
Hey, yo!
4,000 characters, Wes. Yeah. With an additional 12,000 character external expansion box.
You're going to want that.
Which kind of looks like a warp core. Core memory was a popular form of storage in this era back in the 60s and later. And it was relatively fast, quote unquote, and inexpensive. Each bit is stored in a tiny magnetized ferrite ring called a core.
But I think what's great about this is it really lets you see what's happening. If you just imagine a whole bunch of little iron rings with a magnetic charge on them, either a 0 with no charge or a 1 with charge, and then put in a big 3D grid, that's how memory worked.
Yeah, the cores are wired in an XY grid. To access the particular address, one of the X lines is pulsed, and then one of the Y lines is pulsed, which then selected the core where they intersected. And by the way, hence the term core dump. In the 1401, there are 4,000 cores in each grid, forming a core plane that stores 4,000 bits.
There you go.
4,000 cores, 4,000 bits. It's fascinating in its simplicity, don't you think?
Yeah, I mean, this comes from the days where, maybe not totally, but a single person could understand how this works.
You could literally look at how memory was wired.
Hey, look, there's my text file.
The analogy that came to my mind is it reminds me of opening the hood on my 2012 truck versus opening the hood on like a 1940s truck.
Absolutely.
And when I opened the hood on a 1940s truck, I was struck by how I almost understood what everything did, having zero mechanical experience. I've changed oil before, and I was able to look at this engine and go, oh yeah, okay, all right, I kind of get that.
It just makes sense.
Same with this. You can kind of just look at it and go, oh, wow, yeah, okay, I can see that, and visually it makes sense. I think that the simplicity, in a sense, is sort of what I like about this. It's only 4,000 characters, unless you get the 12,000 character expansion
Big
module.
spender, you.
But I couldn't imagine debugging it. And we'll leave this as an exercise for you at home. But they had to go through and figure out what went wrong in this old piece of gear that's been sitting around for a long time. And they had to debug this 4,000 core memory unit to figure out where the problem was, which I guess it kind of gotten fried after like a power outage.
It sure makes for a fascinating story.
It really does. And some really cool shots of old hardware, all of which will be linked in the show notes. Yeah, and we'll just leave it at that. Fascinating read. And it's got a bunch of great pictures of old hardware in there. Well, that brings us to the end of this week's TechSNAP. Now, a production note, we will not have an episode next week, at least if everything goes as planned. I'm going to try to take a little bit of time off at the new year.
And good for you.
We'll be back the next week to our regular weekly schedule, but yeah.
Here's to 2018, the year of new TechSNAP.